Good morning students, your first class in Automobile Component Design Practice Lab. The topic is muff coupling. See, this is your problem sheet from the question 1, 2, 3, 4, 5, 6. You have to write the question number 1, 2, 3 in your lab copy. You can write in A4 page and you have to design this part question number 6 in your A4 page, and you have to draw the muff coupling by using AutoCAD software or any other software. You can draw in your drawing sheet also. All the answers of the question 1, 2, 3 is given in this video. You can find in your book also, that you have to submit in proper date. So what is coupling and what are the requirement of coupling is given in the manual. Now your topic is muff coupling. We will learn how we will design the muff coupling. There is a problem given. Make a neat dimension sketch of a muff coupling which is used to connect two steel shaft transmitting 40 kilowatt at 350 rpm. So from this first line of this problem we can write solution given data P is equal to 40 kilowatt. So 40 kilowatt is given. 40 kilowatt means 40 into 10 to the power 3 watt. We have converted into watt, and N is the RPM. Torque unit is RPM 350. It is given, and this one is the shear stress is 40 MPa. Here it is given. Allowable shear stress and crushing shear stress is given 40 MPa and 80 MPa. So 40 MPa is shear stress and crushing stress is 80 MPa, and allowable shear stress, another shear stress is given, allowable shear stress which is 15 MPa. It is given 15 MPa. MPa means megapascal, which is equivalent to Newton per millimeter square. MPa and Newton per millimeter square, both units are same. And here tau s means shear stress and CS means crushing stress. So first we will start the design of the shaft. We know the D is equal to diameter of the shaft, and the formula is T is equal to 2 pi nt by 60. This is the formula, T is equal to 2 pi nt by 60. So from here we can calculate T, torque. So 40 is given, power 40 into 10 to the power 3, and 60 it is the value, and 2 pi into 350. P is 40 into 10 to the power 3, and N is the RPM 350, and pi is 2 pi. So from this we can calculate torque. Unit is Newton millimeter. It is given 1100, and I have converted this into Newton per millimeter by multiplying 10 to the power 3. So torque is, from this torque is Newton millimeter. Now again we can write that transmitted torque 1100 into 10 to the power 3 is equal to another formula, pi 16 into shear stress into D3. D is equal to diameter and C is the stress. So from here it is calculated that D3 is equal to 140 into 10 to the power 3. It means D is equal to 52. We can evaluate this value of D. This is 52, and I have taken here 55 mm because the diameter of the shaft is 52 is not possible to make. So we take multiple of 5. It means the nearest value is 55 after 52. so I have taken 55. Next is design of the shaft. Design of the shaft, you know the formula, D is equal to 2D plus 13. So here you put the value of D, 2 into 55 plus 13 is equal to 123, and I have taken the multiple of 5, so 125 mm. Next is length of the muff. Length of the muff formula is L is equal to 3.5, D is equal to 3.5 into 55, D is equal to 55, so 192.5, so I have taken 195 mm. Now you have to check the stress of the muff. So this is the transmitted torque, T is equal to pi by 16 into shear stress into D4 minus D4 by capital D. This is the formula, and from this we are calculating the value. Stress is a 2.97 Newton per millimeter square, which is allowable. Since the induced shear stress in the muff coupling is less than the permissible shear stress of 15 mm per meter square, therefore the design of muff is safe. This value 2.97 is within the range of within the lower value of 15 Newton per millimeter square. If this value is more than 15 Newton per millimeter square, then the design is not okay, but it is less than 15, so it is okay. Next is design of the key. As per the table, you know the table is given, diameter of the shaft is 55, so width of the key is 18 and thickness of the key we can take 11. You see, this is the value. The diameter of the shaft is 55, so we have to take this range 18 and 11. 18 is the width and 11 is the thickness of the key. Okay, 18 and 11 I have taken. Then the length of the key in each shaft. Small l, length of the key is equal to capital L by 2. So capital L by 2 is equal to 195 by 2 is equal to 97.5. Now let us check the induced shear stress and crushing stress. This is the transmitting torque, T is equal to, the formula is L into W into stress into D by 2 is equal to, calculating the stress is 22.8. Now considering the crushing stress of the key, T is equal to L into small t by 2 into stress into D by 2. Now again you calculate this value 74.6. Since the induced shear stress and crushing stress are permissible shear stress, so these value are under the range, so the design of the key is. To start the design, first of all we have to set up the page of AutoCAD. So after opening the AutoCAD page, you go to the format and then go to units. Here the units are in millimeter, so from this list you select the units and then go to OK. Then format and drawing limits. Drawing limits, lower left corner you have to put the value 0,0, then enter. Then the upper right corner you have to give the value 297,210, and then in the command line you type zoom and press enter, then select the option all. After then you have to go MB setup command, press enter, then no, then choose the option metric for M, then the scale factor 1, then width 297, and then put the height 210, and you will get this screen. This is your margin. You have to draw the drawing inside this page. Now you go to the dimension and then click at dimension style, then modify, then go to the primary units and select the precision 0.0 and text height 5 and the arrow size you select 5 and OK and then close it. So under this screen you have to draw the drawing. Now then you go to the draw, then text, then single line text, click at the top of the page, then put the text height 9, press enter, then write and click outside of the screen and press escape. Now the page is created and you have to start your drawing inside this page. Now we have to draw shaft. So first go to the line, and through this point you draw line. You take the midpoint, join this line, go to the modify, then offset, and offset distance you take 3 mm, 2 to 3 mm, then select the line, now erase the middle line, now keep the command extreme, delete this inner line. Now go to the spy line, this is the shaft. Now you have to draw the key. In the same way, extend this line, Now you have to hatch this muff, so go to the draw and then hatch. Now add pick points, tick here, press enter. OK. The same way, now I want to hatch the muff, so for that go to the draw menu, then hatch, get pick points, click inside the box, press enter. OK. In the same way you have to hatch in the above the muff, go to the draw, hatch, pick points, press enter. OK. Again go draw, hatch, pick points. Now I have to fillet this corner portion of the muff, so go to the modify, then fillet, then R for the radius, and we put the radius value 5. Now select first object, second object, again so all the 4 corners have done the hatch and fillet. Now we have to hatch the side view of the shaft. Now I have to give the dimension of the object. To linear, and if we enlarge the arrowhead, so go to the dimension, then dimension style, modify, then arrows, and we enlarge the arrow size. I'm taking 4. So this is the muff coupling drawing. All the dimension I have given. Thank you.